Um, Today we're going to do Vernier calipers, right? Vernier calipers is an instrument through which we can find the diameter of the various substances or the objects, what you can call it as. Um, you can see that also you can find the depth of it. There are three ways you can measure it. One is this one, okay, through which you can find the outer diameter, this one through which you can measure the inner diameter, and one more we have, that's this one through which you can find the depth of anything, right? Okay, so I'll just give an example. Suppose you want to find out the outer diameter. Okay, so what you have to do is you have to take an object. Okay, I'll show you. Suppose I take this. I want to find out the outer diameter. What I have to do is nothing but I have to put it like this. So this, if I put it like this, what am I doing is nothing but I'm finding the outer diameter of this, right? So I put it like this, so that's the outer diameter. You have to put it in such a way that it's like this, so you can find the outer one. But suppose I want to find the inner diameter. What I have to do is nothing but it is put it in this way. Okay, now this way, if I put it here, you can find the inner diameter. So go a little deep and here, if I do it like this, so, and if I tighten it, I can find the inner diameter. So obviously the readings will come here only. Okay, when you're doing outer or the inner, the readings will be measured from this only. So that way I can find the inner diameter or something, right? So I release this. suppose suppose I want to find out the depth. So you have to put this in such a way that it should touch the bottom. Okay, so when it is touching the bottom, basically, right, I'm just giving an example. So it may not be the exact object I'm talking about, right? So here is, you have to close it in such a way that you are able to put it the bottom. All right, so it can be, so suppose here it is touching the bottom. Now I have to take the readings again. So here in this case it is touching the bottom, so I can find the readings from here. That will give me the depth of this particular pen cap, right? So I told that it's multi-purpose thing, right? Inner, you can find the outer diameter. This one is used to find the inner diameter. These jaws, they're called jaws, JAWS. That's George. This is for inner, outer, and this is for the depth. All right, and this is vernier calipers. Okay, one more thing I just want to tell you, that vernier calipers, here is, look at this here. Here the marking which is done is in centimeter. Okay, so suppose here I can say that it is 12 centimeter, 12 and 13, 14, 15. So like it's 12.5 centimeter, right? 12.5 centimeter, if you multiply by 10, so that will be into millimeter, right? So the graduation is done on here is in centimeter. Here this is nothing but called main scale. This one, the scale which you can see here, is called as main scale. This is called main scale, MSR. This is called vernier scale, right? Here if you look at this, I'll show you. I use this to show you this. Yeah, you can see that there are some marking here. If I ask the camera person to bring it very close to it, yeah, you can see that there are some lines over there, right? Yeah, so around there are 10 lines. So that 10 lines nothing but stand for the vernier calipers. You can call it as vernier calipers, the lines, what you can call it as. And I'll tell you that how to take the readings and all. So just be aware that we have got two scales here. One is called main scale, the second one is called vernier scale. I'll go about in detail how to take the readings of this, right? So this about this instrument. This one is which we use to drag it, okay, and right and left. Okay, this is a screw which we tighten. Okay, if you want to tighten and keep it somewhere, so you have to just tighten the screw. So this is all about this, right? Okay, so first, before we do this, we need to have the least count of this Vernier calipers, right? So I'll go about telling you how to find the least count. So let's check how to find the least count. Okay, what do you mean by least count? Least count is nothing but the minimum measurement. Okay, the minimum measurement which is possible by an instrument is called as least count. So let us understand how to calculate least count. Okay, to understand that how to calculate least count is nothing but, let me tell you, the least count of this is 0.1 millimeter, which is nothing but 0.001 centimeter, because millimeter, if I divide by 10, that will convert into centimeter. So 0.1 millimeter, which is nothing but the 0.001 centimeter, right? So this is the least count, right? How to get this least count, I am going to tell you right now. Okay, now look at this here. If I show you this main scale, here is main scale. Here each division is nothing but, we call it as 1 millimeter here on main scale. Since we have, I told you that it is a centimeter scale, so 12.5 multiply by 10, that's, so here is each is nothing but, if you say this is 12, this is 120 millimeter, what you can call it as. So here each division is in 1 millimeter, right? So I will write here main MSD. Okay, each division which is out there is nothing but main scale reading. I write in main scale division is nothing but 1 millimeter. So I've got the that way. uh, so these, or each line stand for 1 millimeter. All right, now the second one is nothing but, I've got vernier scale here. So as I showed you that vernier scale, I've got this. If I take it very close, if I take this one and I make you actually count, okay, if I make you count here, yeah, if I make you count, just a minute, hold on, because it takes time to adjust here, because there's a reflection coming up. So yeah, you can see that. If I show you, look at this, when I'm saying here, this is the lines. So if you count here, it's 1 2 3 4 5 6 7 8 9, and this is the 10. So you got 10 lines here total. So that is 10 line. Okay, and it is always told that, and it is proven, rather, I'll tell you the facts, though it is yeah. So what did I show you there is, there are 10 lines, but 10 lines of this vernier scale division is equals to 9 line of main scale divisions, right? So 9 lines of main scale division is equals to 10 lines of vernier scale divisions, right? So I repeat, okay, 10 lines of vernier scale division is equal to 9 lines of what, main scale divisions, right? I write it here in front of you so the things are pretty clear here, right? 10 vernier scale division. I write here vernier scale division is equals to 9 main scale division. Okay, so what will be equals to 1 vernier scale division? So 1 vernier scale division will be equals to 9 upon 10, which is 0.9 mm. 0.9 mm. So what will be the least count? Least count is nothing but the difference of one main scale division minus one vernier scale division. So what is one main scale division? Is nothing but 1 mm minus what is one vernier scale division is nothing but we got just now 0.9 mm. If I subtract this, I get 0.1 mm as the least count. I told you the least count is going to be 0.1 mm, and that is what we got from these acts. So we got the least count of this, and if I want the same thing in centimeters, so least count will be 0.1 mm divided by 10, 0.01 centimeter. This is the least count in centimeters. So now students, you need to remember this. If you don't remember the least count, you cannot take the reading. Very simple. So keep this in mind, and then we'll start taking the readings. Alright, so this is all about the least count. So you have to remember that anyone you remember, millimeter you remember, will convert into centimeters, not an issue. That's very simple thing. Right, now I'll tell you how to take the readings, right, in a vernier scale. So I just remove this and I tell you that how to take the readings in vernier scale. Okay, so yeah, how to take reading in vernier scale. Right? Okay. Now let's see how to take the reading in Vernier calipers, right? Okay, this is the instrument, right? Vernier calipers. I told you that this can be used three ways. That is the outer jaw, inner. This is the for the inner diameter, outer diameter, and this is for the height. Okay, what I do is I take a bead, right? I have a bead with me, right? I take that bead. Okay, so I take a bead. I have a very small bead with me. All right, not an issue, right? I take it and I put it into this jaw, right? So I put it into the jaws here. You don't have to take it top, right? Take it here. Okay, need to be very careful when you put it here. Okay, so I put it here, and now I'm going to take the readings here. Okay, so let's start. First thing, before I take the reading, I had to tell you something. First, you have to join these two jaws, and you have to look for there is something called as zero error. Okay, means what I'm supposed to tell you is, first you have to look at the zero of the main scale, this zero, and the first line, that's the zero of the vernier scale, right? Both should coincide, both should match, they should form a straight line. If they are forming the straight line, you can take the reading, and even if they are not forming the straight line, still you can take the reading, but then that's counted as zero error. but when they are coinciding, it means there is no zero error. So zero error is nothing but basically it is a system error, okay, the device error, which we either add it or we subtract it, depending on that what kind of zero error is. So here when I look at this, since both are coinciding here, that is Vernier scale 0 and the main scale 0, they are coinciding, so there is no zero error. So zero error, let me write here, zero error is 0. Zero error is 0 here because there is nothing, no zero error, or you can put it as simple, right? So our job has become very simple because there is no zero error. But there are devices where there can be a Vernier calipers, okay, their technical errors are possible, so they can be a zero error. But how to deal with that, I'll tell you later, right? Let's talk about the how to take the reading through a Vernier calipers. So take this bead, put inside, like I put it inside. Now if you're comfortable, you can remove this, no problem. Keep it aside. Now let us start taking the reading, okay. First you're supposed to take the main scale reading. Yeah, you're supposed to take the main scale reading. Main scale reading is nothing but how will you first find the main scale reading. To find the main scale reading, what you're supposed to do is nothing but you have to check with the first vernier line. The first vernier line is coinciding with which one, okay. For example, if I take this camera very close to here, okay, yeah, you can see that here is the first vernier scale line, okay. The first, I'll show you, look at this here, this is the first vernier scale line. This is before 1, it is not at 1 but just before 1. I'll make it quite clear here. Yeah, now you can see that the down line looks a little black here. This is before 1, means between the ninth one and the 1, okay. Means this is 9 and 10, 9 millimeter, and this is the 10 millimeter, so it's in between. So I will not take the 1, I will take this one before that, means this 9 millimeter. So for me the main scale reading has become 9 milli. Always you have to take the preceding one, not the next one. So always take the preceding reading. So here the reading has become 9 millimeter, or you can say 0.9 centimeter. All right. Yeah, are you clear about this reading? Yeah, you can see that here the reading is exactly 9th line and the 10th line, okay, in between that. So you will take preceding reading, so I take it as 9 mm, right? So the vernier scale, right here is we'll write first main MSR, which is main scale reading. So main scale reading is you can write it as 9 mm. So main scale reading is 9 mm, right? We go for the vernier scale reading. Vernier scale reading. Vernier scale reading. Yes. Okay. How to take vernier scale reading? Again, this will be little difficult, but then we have to find out that. Okay. Other than 0, in a first line of the vernier scale, the first line, leave the first one. Apart from, you check which one is exactly coinciding you have to check that which one is exactly coinciding with the main scale. So I just put it here. Okay, you can see that which line is exactly coinciding with the main scale. Okay, I try and show you. Look through this and we find that Vernier calipers, look at this here, I'm showing you this, this line is exactly coinciding with the main scale, right? So here I would say let's count 1 2 3 4, and this is a fifth line. The fifth line is exactly coinciding with the main scale line. So the Vernier calipers, whichever line is exactly coinciding with the main scale line, and it is making coinciding when it's making straight line, okay, that particular line. So I took the fifth one, fifth Vernier calipers. Okay, so fifth Vernier calipers reading is exactly coinciding. So I'll show it again here. Okay, for me, if I find that this line, this is the fifth line, this bigger one. Okay, you count here 1 2 3 4 5, this is the fifth line, is exactly coinciding with the main scale. So that will be my Vernier calipers reading, right? So let's start writing that. Here is Vernier calipers reading is always multiplied with least count. So you remember that 5 is the Vernier calipers reading which you took it. Okay, and this 5 will be multiplied by 0.1 millimeter, which the reading the you had the least count. So this has become 0.5 millimeter. Okay, so your 9 mm is the main scale reading, and VSR, that is Vernier scale reading, is come out to be 0.5. Now what you have to do is nothing but you have to add both of them. So when you add both of them, so you say the total reading is equals to MSR plus VSR, that is Vernier scale reading. So my MSR is nothing but here is 9 mm plus my VSR is 0.5 mm. So if I add it, how much I get? 9.5 mm. So the reading is, the total reading is 9.5 mm. This is the reading, okay, which you got it, but this reading is in mm. If you want to convert into a centimeter, so this 9.5 mm will be divided by 10. All right, so which will come as 0.95 centimeter. This is nothing but the reading of Vernier calipers for that particular bead. Okay, the bead which we took, okay, the diameter of that bead is going to be 0.95 centimeter, right? So this is all about how to take the reading from a Vernier calipers. Okay, as I promised you, I'm going to tell you the how to calculate zero error. Suppose here the zero error was 0, so we had no problem of calculating these readings. I mean, they simply just came out, right? But if there is a zero error in that, what will you do, right? So now I'm going to tell you, if the zero error is there, what to do, and if the zero error is and what kind of zero errors are possible. So let's, yeah, let's see. There are two types of zero error. Okay, one is positive and the second is negative. Okay, positive and negative. Always remember Okay, that positive will be subtracted, subtracted, and negative will get added. How and what, I'm going to show you, right? So positive readings, this one will get subtracted, whereas this one will get added, right? Okay, when is the positive error and when is the negative error? You know what, for my knowledge, for my understanding, I have a thesis, or you can say a mnemonics made by me, right? What are the mnemonics? I'll just share with you. Yeah, you might laugh once you hear this, but yeah, this is how I remember, and you have to form your own ways to remember, right? Okay, you can see that right now, since 0 of vernier and the 0 of main scale, they are coinciding to each other, so there is no 0 error, right? Okay, but it might possible that the sometimes this the vernier scale, okay, our reference is main scale 0, right? Your reference is to main scale 0, that will remain at its place. Now this vernier scale reading, the first line, the 0 line, this vernier scale, it might remain before this main scale 0, or in some instrument it can go ahead of 0. Okay, so like if it goes ahead of 0, okay, then what, and if it is before the 0, what it is, right? So what is my mnemonics is nothing but here is, okay, now suppose it goes here, if it is here before 0 of the main scale, you can see that the main scale 0 is here, but the vernier scale 0 is here, so it's before. So for this, how do I remember this? Nothing but it's BPO. What is it? BPO. If vernier 0 is before main scale 0, okay, for me it's B po. BE means it's before, and po means it's positive. Okay, means this reading, this 0 error will be positive for me. Second one, if vernier 0 is ahead of main scale 0, then for me it is an A. A means ahead and nay means it's negative. For me, this 0 error will be negative. This is how I remember. You can have your own ways, because this is the only problem which you face, which will be positive 0 error and which will be negative 0 error. So this is my positive 0 error, which I told you will be subtracted. This is my negative, which I told will be added. So yeah, look at this here. Since, as I told you, that my instrument is error free, okay, since my instrument is error free, just for sake of you to understand the how to take the 0 error and how to subtract and add it, I'm just telling it, but please understand that this is error free, the device. But yeah, just for you to understand, what will you do? Suppose here is this, look at this, my vernier scale is before the main scale 0, right? Okay, so my vernier scale is before main scale 0. Now yeah, so you can see that my main scale 0 is ahead, and the vernier scale, as I told that it is before, it's, so I told that here is before is BPO, that is positive. So here what I have to do is, other than this the first line, I have to check which line is exactly coinciding. So suppose which line is exactly coinciding here, that line you have to take it as exactly coinciding with the main scale. So vernier and the main scale which is exactly coinciding, that one you have to take it as the reading. Suppose here the reading is taken as for me the again I can find that the fifth one is exactly coinciding. Yeah, I can see that the fifth one is exactly coinciding, and the big line which is out there, the fifth one is exactly coinciding. So what is the reading, what is the zero error here going to be? So in this case, zero error is zero error will be, okay, fifth line, okay, fifth line as I told, multiplied by least count, that is 0.5, and this is positive, so you will write it as plus, this is positive, so this is plus 0.5. So whatever the total reading is there, in that this reading will be minus plus this 0.5. So suppose your total reading is 9. If you remember that we had the 9.5 mm. Look at this here. For example, let's say the reading is 9.5 mm. Okay, so if it is 9.5 mm and the zero error is 0.5, so I told that positive is always subtracted, so it is subtracted and my final reading will be 9 mm. So this is in case of positive, that is BPO. So always the positive errors are always subtracted. So here is the positive error which I am subtracting, so my final reading is 9 mm with subtracting and adding, that is whatever the zero error was there. After that, this is okay. Yeah, now let us see if the zero error is negative, what is to be done. So if the zero of the vernier scale is ahead of main scale 0, right? Okay, check it out here. What is the formula you're going to have? The total main reading, okay, the reading which you have calculated earlier. Okay, the total main reading is nothing but let's say this is the total reading which we have calculated earlier, remember? Okay, so this is the total reading, okay, minus, okay, this is the minus sign, every time we have to subtract. Okay, in the bracket what we have is, it is going to be negative. This is when it is ahead of this is called negative, so I'm taking negative sign here. In the bracket, the total, this is the total vernier scale division which is 10 minus coinciding vernier scale 9, okay, into the least count, okay, least count of the vernier scale, right? So let us talk about it here. Let's say the main reading is 9.5 mm which we have calculated, okay, and the coinciding vernier scale division is 3, okay, which should be subtracted 10 from 10. 10 is the total vernier scale division here. So you can look at this. I'll show you this instance how it is happening here. So look at the diagram here. Okay, so below one is the vernier scale divisions here, and the above is the main scale divisions here, right? So look at this here. This is the vernier scale 0 which is ahead of main scale. So in this case it is negative. So what we have to do is we have to search the coinciding division, right? So I'll see this is 1, 2, third. Look at this, third division is coinciding with the main scale. So this is become coinciding vernier division with the main scale, okay, which is 3. So now this 3 will be subtracted from the total vernier scale division. So total we have 10. Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have got total 10. So from this 10 will be subtracting this 3. So let's say if you do that, how much it comes? So 10 minus 3, which comes to 7. So this is going to be 7, which will be multiplied with least count. Can you see that here? So 10
minus coinciding Vernier scale line. Coinciding Vernier scale line is 3, third line, which is subtracted from here, into the least count, okay, which is 0.1. So we are going to do that. Look at this here, I have done it for you. So this is a total reading 9.5 which I have, minus of, this is negative, against here is in the bracket 10 is the total Vernier scale division, minus of 3, the coinciding Vernier scale divisions as per the formula here, into the least count. Least count is 0.1 millimeter, right? So here is 9 point as it is, here is 10 minus 3 is 7, so this has become minus 7 here, into least count, that is 0.1. so again here 9.5 minus of minus 0.7, okay, which is nothing but 9.5. again we write this minus into minus is plus, so it has become plus 0.7. now when you add these two, you get 10.2 this is the reading when you have got a negative 0 error. So when you have got a negative 0 error, finally that after subtracting from that, gets added. So this is the thing is, so this is the final reading from the negative 0 error. Thank you very much. Wait for the next video. Please subscribe this video. Thank you so much.